Welcome everyone in the next session of Intelligent Transportation System and Traffic Management. My name is Dr. Asim. Today we will try to understand that why do we need environmental data. Uh, on the screen you can see the two typical example of fog and smoke. So that specific terminology, folk, is usually linked, or maybe you already observed such type of a uh, issue, or might you already face it in the early morning. So this is one of the typical example of the atmospheric phenomena which impact visibility, which reduce visibility. So we will try to understand it. What are the different phenomena apart in terms of formation and how the human activities can influence in the smoke as well as in the fog situation. When we are trying to understand smoke, so smoke is actually the combination of a fog plus smoke. Okay, so this is the kind of a coin term which describe the extreme air pollution. Okay, so here we are usually referring it to the industrial waste or the chemical waste or the chemical pollution. But here, this is completely the environmental issue. Okay, so whenever we have the fog or haze, so that state actually described that air is saturated in the liquid or in the solid form. So smoke also contains many kind of a gaseous components as well. Okay, but at the end of a day, both of those terminology, fog as well as the smoke, it reduce the visibility for the drivers. Today, in that specific lecture, we will try to understand that what are the different detection of the traffic related phenomena, whether it's on the road surface condition, and we will try to understand it. Why do we need, or why the environmental data computation or analysis is actually required? Okay, because we required it for the three purpose. The first is to provide the estimation and prediction about the situation, and then also to confirm the data as well, and then to control the traffic management as well, because we need to control all the entry and exit points if the situation is, for example, bad in like that specific part or section. And so we already estimated the same data that that specific portion visibility is still less than 50 meters. So like for between one to another vehicle, we cannot see beyond 50 meter. So we actually needed or like required to identify that specific spot in part, and we also need to restrict the entry and exit as well, so that for the travel safety purpose. And such type of issues usually occur on the main motorways and on the primary roads. Okay, and what is our purpose, or why do we require that data? Because we want to secure a high quality, we want to secure the high quality of traffic safety. Secure means ensure. We want to ensure a high quality of traffic movement in terms of accessibility as well as the safety. Okay, movement and safety. And that part can be done through different streams such as the adaptive control system, and as well as to provide the different condition to the user before time. So we are trying to understand those four phenomena which are directly connected with the visibility or smoke. Okay, the first one is the physics of the driving. So of course, whenever we have visibility, what will happen? Okay, so the traction between road and vehicle will be increased. We will also transform our transferable radial forces. Okay. And we will have the balance of the vehicle will also be affected. So all those parameters will actually reduced. Okay. And the braking distance will increase. So if the braking distance is increased at like 100 or like 120 kilometer between two like vehicles, so of course we actually might require 100 meter between two vehicles for the safe journey. But if we have the visibility issue and we are not even able to like see beyond 20 or like 30 meter, so might be one vehicle is here and another one is here, so we might have the increased number of the accidents as well. The second part is the traffic safety. According to the one study, more than 17% fatality accident cause only due to the critical environmental condition. And of course, we have the speed is reduced, the flow q, which is equal to k into v. That specific flow is also reduced, and of course, capacity is also reduced. Okay. Now we are trying to understand. So this was all about safety, and this is all about traffic flow. Now we are trying to understand economy. Look, it's a very simple concept. Whenever, for example, if this is the spot which we consider, and that specific spot is 100 kilometer from origin to destination, and at the speed of 100 kilometer per hour, that will take 60 minutes. But due to visibility or operating speed is 30 kilometer per hour, so that specific portion from origin to destination might take 3 hour and 10 minutes. Okay. So you can imagine the consumption of that vehicle within 1 hour, and now the consumption within 3 hours. So of course, apart from the increase in the accident, the delays, the operation, the emission cost, along with the cost of the fuel is also increased. So now you can imagine that why do we need environmental data and how it is directly connected with all those four different and important parameters. So now we are trying to divide it in the different domains so that to understand it. The first one is the kind of a primary parameters. So in the primary parameter, which are basically responsible for the controlling of the traffic management system. So we might have the visibility range issue, and then what kind of intensity of the rainfall or the precipitation we have, and what is the thickness of that road surface or the road water film which is actually existed in the road in terms of the millimeter. And then we will also try to understand that what is the different condition which are related to the freezing temperature, the road surface temperature, and of course the different type of the road as well. And then if we, so those are kind of which are directly connected, are directly involved, and those are the one which are indirectly. Those are also directly involved parameter as well, but for example, air temperature is also might be usually according to statistic, if we have the higher temperature, so overall the efficiency of the vehicle also kind of reduced. And then we have the relative air moisture as well. Of course, if we have the higher, for example, if vehicle is moving in like that direction, and at a speed of 50 knot per mile or like per hour, and the opposing is like more than 70 knot. So of course, there will be the drag force will be applied on the same vehicle to move it in the forward direction. Okay. The same if we have the higher rain situation like precipitation, we might not able to maintain the same speed. And of course, wind direction is also possible if it's moving from like behind, from like back, so it will move it in like the uh, it will push it from the back to the forward direction. But if we have the front to like back, so then it will drag it in the back direction. And if it's in the lateral movement, so it will affect the overall moment of the same vehicle. So now we are trying to understand that how it actually works. So in the previous two slides, we understand that this condition is very much important. So now we identify that specific condition. So this session is most like mainly about to understand the importance, and also that how or what kind of devices do we have, do we exist through which we can predict or ensure the safe movement. Okay, so this is, for example, our regular roads, and we have different kind of a devices which we will explain it in the next slides. And through those variable message signs, through those algorithms, we actually controlled traffic, and we give them the kind of a information regarding speed, slippery situation, which kind of turn you can take or which kind of turn you cannot take, etc. Okay. And then we have, of course, vented services as well. For example, if we have the snow path, so with the salt, we are trying to clear the same pavement surface as well. Okay. So how the system actually work? Okay, before to jump in like the observation different parameters, so you need to understand once again that we have the first stage is data collection, and then are which we call the data collectors as well, which we already covered in our previous slides. And then we have the on-site generation of the same data. So like it actually cluster the same data and provide it to the algorithm through that modern sub center to the which is connected with the main center. And then in the main center, through the data fusion, we actually analyze the same data and then send it to the in the form of variable message signs. Okay. And then through that controlled measurement, we actually recommend different kind of a uh, kind of strategy to ensure the safety, or for example, if we have disturbed visibility, if there is an accident ahead, so we need to inform all those vehicles before it reach to like that specific spot or pot. So now if we are trying to monitor the classic weather, so we have different methods. Okay, so this is the method which is called the kind of a compilation of the or the analysis of the measurement of the weather data, so that we can understand it how much the snow is basically in the depth condition. So we have mast system with different kind of arms which separated, and which is actually working mainly on the single sensors. Is like that. You can see here it is installed within the pavement surface, and it's connected with the solar panel. Okay, so we don't need any batteries for like longer run, and we have the automated remote data transmission from like those devices to through that solar panel to that control device. Okay, and then it is connected. So those are the kind of a sub center, and which is again connected with the main center. Okay. So the two important issues in this session we will try to understand. One is precipitation and another one is fog or smoke. Okay, so what is precipitation, or how much intensity or the kind of a state of precipitation or like rain we can count. So we count that part in the millimeter per hour. Okay, and for example, if we have that value on that device is 0, so that means that we have normal condition. If it's up to 42, so that means like 42 millimeter per hour. So we actually consider it the kind of a just normal precipitation. And then if it's reached to like 50, then it reached to like mist condition. And if it's like below 60, then we have special condition. If it's above 60, then we have like fluid kind of a precipitation. If it's more than 70, if it's above 70, then we have completely frozen condition. If it's above than 73 or like 76, so then we have completely extreme frozen condition. Okay. And then if it's so like all those devices, they have intensity to like measure it till 200 millimeter per hour. But this is one of the most extreme situation. But if it goes beyond almost 200 or like 220, so it is very hard for like even that device to quantify it or give it the value according to the its definition. Okay. So those are different devices. The first one is about the optical, which we called infrared light barrier, as you can see here. So we have that infrared devices. So this one is its starting point. This one is its ending point. So it actually pass the infrared signal, and according to the size of precipitation in like terms of a length, width, and its height. So we can receive its signal. So one part is basically working on so that part is like light bank. This one is the optical source, and this is the receiver. So this is the receiver, and this is optical source. So through optical source, we are trying to identify the different precipitation through the light barrier system. And the second part we have uh, through which we are trying to identify the infrared light beam system. So through that specific system, we are trying to measure each and every particle on that specific infrared light beam, and we are trying to understand that how many, for example, if this part is, for example, 10, 225 millimeters, or like we can imagine it for like 25 meter. Okay. So we are trying to understand that in that specific height and that specific width, in that specific length, how many, what is the intensity of precipitation, which we measure it in terms of millimeter per hour. We can also identify its type, and we can also measure the visibility as well. So what kind of different elements which we actually required, we can understand the from the number of particles, speed of particles, and size of the particle, so we can identify its characteristic. The next part, we have the sensor technology. Okay. In that sensor technology, we have the that specific part is connected with the temperature sensor, which we call. This is overall the total thickness which we consider on like that above radar surface, and this is our electrodes, or which we call to measure the freezing temperature as well. And this is the radar rain sensor, through which we can, of course, derive the amount of precipitation along with the visibility, which we measure it in the meter. Okay. So if we are trying to understand the visibility range, so the maximum distance from which an observer, for example, this is observer 1 and this is observer 2. Okay. For example, one is moving here to observer 1 and this is observer 2. So what is visibility range? So if we are trying to understand, so we can define it the maximum distance from that observer driver, from that distance at which he can manage to see any object. So that object could be man-made, and it could be moving one as well. So for example, car, okay? And what is the limitation of that visibility, or how it could be increased or like decrease? So its important element is, the first one is of course fog. The second one is precipitation. And of course, during night and day, so we have two extreme situations which we should consider. And then pavement condition, which we call, for example, if the road is wet, so then if there is a kind of a snow as well, as you can see here as well. So how we can ensure that that specific surface is already clear and it could be used. So those are different devices which we use to detect the visibility through the scattered light system. And that fog might be consist of a very small drops, okay, as you can see here. And the light which we send it from that beam is scattered, so that through that specific sensor we can identify the specific drops in, like so on. The denser the fog, the more water drops will be inside that sensor, okay, that detector. So from the drop volume, it can identify the intensity, okay. And then we have, of course, the scattered light intensity, which is directly converted to the standard visibility range while using different algorithms. So what kind of important requirement do we require to ensure, or what kind of environmental data and control we actually required to ensure the traffic safety? Look, you need to understand the two important characteristics. The the first is the high quality of the data that will ensure the safe movement, along with the stationary requirement through which we can derive the environmental data within specific location according to time, according to location, according to coordinates, and then the same data will be conveyed to the users, so that they can control, or might be they can reroute their decisions according to situations, according to warning, and according to speed limits. So all those information that could be generated from those devices if they are working perfectly. So in a simple word, so this is stage number one, from which we collect the data, and then we have data analysis or like fusion, and then we have the variable message signs. And then the fourth stage is that we are trying to see that either we ensure the safety of the traffic or not. So this is the typical example of the manual warning of the slackness. So when we detect the state, or which we call slackness, or the potential slackness due to the icy condition, or the kind of a frozen wet condition of the same pavement, by using different surface model, and then we are trying to initiate the warning regarding to that slackness, which could be displayed for the operator for the same driver, so that that's kind of an unplanned or uncertain situation could be avoided. As you can see here, the problem which we might face, or the practical experience, just to show you that how the inadequate or insufficient result might cause a lot of problems. Okay, so we might have the issue of the any object identification, number one, if we are not receiving the data. The second, we might have the uh, n homogeneity of the events, that where that part was detected, and how much that event was stretched. Stretch means the lag time, the duration. And then we have the subjectivity of the events, such as to see like the kind of a classify its borders, and then detect the event different. And then we have, of course, the quality monitoring system management as well. And we also would like to, for example, in a simple word, if we are not getting the required data, so for example, the stretchness of that event, the detection within the geospatial pattern, and the inhomogeneity through which we can decide our next movement. So we might lose a lot of information and we might not be able to provide the safe movement. This was the traffic, the typical example, which was initiated in Munich, Germany. So that information resulting from the fusion process, which were put it for the experimental setup. As you can see here, the aim of that project was that how we can improve or detect. So one is improvement, and then second is detection of the road surface condition through the following the FCD. Okay. As you can see here, so we, according to the Munich system, so they installed different kind of a sensor system, different navigation system, different detection loggers, along with different cams, along with different kind of a recording device. So this is the experimental setup. As you can see here, those are the few glance. Okay. And this is at the end of a day, it's like result. Uh, this specific position, so on the very regular basis, is the ITS developer and planner. We usually generate the different reports regarding different fleet, regarding different fleet of like vehicle or like jams, and because we receive the same data, it from the time span of a 20 second up to 5 minute, like 300 seconds, or might be 350 seconds. Okay. So, so then we are trying to process that data for the purpose to determine the route section through which we should travel. For example, this is the kind of a typical example which we are identify. So for example, if this is your origin and this is your destination, so we already solved that problem in our previous lecture. We are trying to go from here to like there. While moving from origin to destination, we should be ensure about the turning moments. We should also be sure about the capacity along with the resistor. And then, of course, each and every algorithm, either it's a static algorithm, either it's the shortest path algorithm, or it's a DJ Castro method. So all of them would like to ensure to kind of reduce length, ensure the free velocity, along with the less longitudinal slope, higher capacity, and also so that we can reduce the resistor as well along that length which we selected. Okay. So this is your typical example for the quiz number 3 and 4. While using that specific algorithm, DigiCastra, I would like that each and everyone should identify it from I to L, okay, and then submit it via MS Teams as well. Okay? Thank you very much. If you have